Exercise 4 here, we have a small box with a rectangular base, altså rektangulær grunnflate, altså bunnen her, with a length of 3x centimeters this way, x centimeter this way, so 3x this way, x centimeters this way, and y centimeters this way. And the sum of the length and the width and the height is 12 centimeters. So this means that 3x plus x plus y is equal to 12, which means that 4x plus y is equals to 12. And it says write down an expression for y in terms of x. This means that we should find an expression for y. We need to isolate y here, so y is just move over 12 minus 4x. So that's exercise A. Exercise B, find an expression for the volume, and the volume, this is an optimization exercise again, and the volume, of course, of a box is length times width times height. So the volume here would be length is 3x, the width is x, and the height is y, but we can't use y here, but I get 3x squared here, and then times y, but y is the same as 12 minus 4x, right? So then we have the volume expressed with x. So we get 36x squared, just multiply here, minus 12x to the power of 3. So that's the answer on exercise B. And it says in exercise C, find x such that V is maximized. So we want to maximize this volume. So we need to find the maximum point. And of course, to find the maximum point of any function, we have to find the derivative and put it equals to 0. So I just move 2 down here, so I get 76, so 72. Put 2 down, 36 times 2 is 72 times x. And then I put 3 down here, so I get minus 36x squared. So this is the derivative, and then I put this equals to 0. Like this, to find minimum and maximum points. And here is just 2 terms I can factorize. 36 is a common factor because 72 is 36 times 2, and x is a common factor, so I can put this outside. Then I only have the number 2 left in this term, and here 36 is out, x is out, then we have 1x left, so it looks like this. I'm going to factorize, and then one of the factors need to be 0. 36 is not 0, but one possibility is x is equals to 0, and here we see that x can be equals to 0. So this means that the volume here have 2 stationary points, max minimum points, but this is probably not the maximum point, right? But we should draw some sign lines just to confirm that this is the maximum point. And then we just do like this, take all 3 factors, and 36 is positive. This is a positive number. X is 0 here, negative here, positive here. But 2 minus x is 0 here, and if x is less than 2, since this x term is negative, it's the opposite of what it usually is. It's plus here and minus here. So then we know the sign of every factor, and then plus times minus times plus is minus, multiplied by 0, 0, plus times plus times plus is plus, multiplied by 0 is 0, and plus plus, times plus plus minus is minus. So that's the sign line of the derivative, which means that the function is decreasing, increasing, decreasing. So this is a minimum point, and this is a maximum point. And that's just to confirm that this is a maximum point. So the answer on exercise C is x equals to 2, and the volume is maximized. And then find the maximum volume, then we can just put 2 into the volume function, which we have up here somewhere. And there it is. This is the volume. Sorry. So we get 36 times 2 squared minus 12 times 2 to the power of 3. So this is 36 times 4 minus 12 times 8. And this is 144 minus 96. So that should be 48. It was centimeters here, so it's 48 cubic centimeters. That's the maximum.